Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 12, delivering information directly to the shop floor. Too many operators work blind, without access to updated goals, instructions, or alerts. The result? Mistakes, delays, and unnecessary stress. In this episode, we explore how mobile apps, digital dashboards, and real-time instructions can transform communication on the line. You'll hear how factories cut errors, improved responsiveness, and boosted motivation just by putting the right data in the right hands, instantly. Factory on Air is brought to you by DBR77, the platform that brings real-time production intelligence, alerts, and instructions straight to your frontline teams. Let's get started.
Welcome to the Deep Dive, where we slice through the noise to get to the core of what truly matters. Today, we're stepping onto the factory floor, a place most of us can picture. The rhythmic hum of machinery, the precise dance of production lines, and that constant, relentless push for efficiency and quality. But what if the most crucial ingredient for all of that information isn't flowing freely? What if it's not reaching the very people who need it most, right there on the front line, at their workstations? That's the challenge we're immersing ourselves in today. All too often in industrial settings, production line workers are operating without immediate access to vital, up-to-date data. They might be unsure of the day's precise production targets, maybe grappling with outdated work instructions, or completely unaware of critical plan changes that were just made minutes ago. And this isn't merely, a minor frustration. It leads directly to preventable errors, costly downtime, and a significant, often hidden dip in overall productivity that can ripple through an entire operation. So our mission for this deep dive is clear and compelling. We're going to unpack exactly how modern technologies, with a specific focus on mobile applications and highly visual virtual instructions, are fundamentally revolutionizing communication on the factory floor. We'll explore the tangible, measurable benefits these innovations are bringing, navigate the common challenges companies encounter during implementation, and crucially, identify the practical steps you can take to make these transformative changes a reality in your own manufacturing operations.
Exactly. And to make sure you receive the most accurate and actionable insights possible, this deep dive is built upon a detailed analysis of source material specifically focused on this critical task, delivering real-time information directly to workers at their workstations. We've meticulously extracted insights into how innovative platforms such as, DBR77, for example, are leading the charge in this essential transformation, providing integrated solutions that span from robust data collection right through to intuitive real-time instruction delivery at the point of work.
Okay, fantastic. So prepare yourself for a truly illuminating and, dare I say, maybe even entertaining conversation. We're going to uncover some surprising facts and provide you with actionable insights that are directly relevant for any professional industrial manufacturing looking to truly empower their workforce and elevate their operational game. Let's dig in. Okay, let's unpack the fundamental problem then. What truly happens when production line workers lack immediate, accurate operational information right at their fingertips? It might seem like a simple oversight, maybe, but the cascading effects can be pretty devastating for a manufacturing operation, impacting everything from product quality right through to employee morale.
Absolutely. The consequences are far-reaching, and they directly impact efficiency, quality, and ultimately profitability. It's huge. When workers don't have real-time data, you inevitably see, disorganization and inefficiency permeate the entire workflow. Imagine an operator deep in the assembly process, needing to confirm a specific bolt torque or maybe a wire routing detail. If they have to leave their station, walk over to a supervisor's desk, maybe wait for an answer, or worse, sift through some dusty, outdated paper manual. That's minutes, maybe even tens of minutes of lost productivity right there. Tasks might get performed in the wrong sequence, leading to wasted time and effort, or even requiring complete redos later down the line. It's like trying to build a complex Lego set without the instructions, or worse, with outdated ones you're just fumbling, backtracking, and definitely not building efficiently. The frustration for the worker is palpable, and that translates directly into lower output.
That mental image really drives it home the sheer waste of time and human energy. It's not just trivial. But beyond just wasted time, what about the direct, measurable impact on the product itself? Does this lack of information hit the bottom line through quality issues?
Oh, it hits it hard. That's precisely where quality and assembly errors come into play. If workers are operating with outdated or missing instructions, or maybe if they're simply not aware of a last-minute design change or a critical specification update, they're almost bound to make mistakes in assembly or processing. This directly impacts product quality, leading to higher scrap rates, more rework, and ultimately an increase in customer complaints and warranty claims. It's a really costly loop that can severely damage a company's reputation and its financial health.
Okay, so give me an example. Like, what could happen specifically?
Sure. Imagine a critical tolerance for a machine part changing due to, say, a new material specification. But the operator isn't immediately notified. They continue producing to the old spec, and suddenly you have a whole batch of non-conforming products. Now, these need to be scrapped or laboriously reworked at significant cost, or maybe even worse, they pass through inspection and fail in the field.
Oh, no.
Leading to potentially costly recalls and definitely reputational damage. It's a serious risk.
Yeah, you can see how that escalates quickly. Yeah. And beyond the errors and the rework, there's the inevitable slowdown, right? The notorious waiting game that just grinds production to a halt and affects throughput.
Precisely. Production delays and costly downtime become an unavoidable reality in that scenario. Workers find themselves waiting for information, maybe waiting for clarification from a supervisor who's busy elsewhere, or waiting for the correct instructions to arrive from an office somewhere, or perhaps waiting for a quality check that isn't instantly logged and visible. This creates bottlenecks all through the line, leads to unnecessary stoppages, and severely impacts overall throughput. Every minute a line is down, or a worker is just idle due to a lack of immediate information, is a minute of lost production capacity and, frankly, lost revenue.
Yeah.
It's a kind of silent drain on resources that often goes unquantified but is deeply impactful. This isn't just about lost widgets. It affects lead times, customer commitments, and your competitive edge in the market.
Okay, so if that's what happens when vital information isn't there, let's flip it. Let's talk about the ideal state. What information do workers actually need at their fingertips instantly to avoid these pitfalls and perform their jobs effectively, even optimally?
Yeah.
What defines that ideal state on the factory floor?
Well, the ideal state is really about empowering workers. It's giving them immediate, contextual access to all the critical data that directly pertains to their current task and the overall production flow. This includes several key categories. First, they need clear, real-time production plans and immediate updates on order status.
Okay, like what specifically?
Workers need to know their daily targets, how much progress has been made against those targets throughout the shift, and the precise status of the specific orders they are working on right now. That includes any rush orders that might have been prioritized. This gives them context, helps them prioritize their own tasks, and allows them to adjust their pace proactively. Without this, they're basically working in a vacuum, unaware of how their individual output contributes to the larger goal for the day or the week.
Right, context is everything.
It really is. Second, beyond that overview, they need the granular detail of technical operation parameters. This means precise settings, exact tolerances, and specific specifications for the current task or machine operation they're performing. Think of it. If a machine needs to heat a component to exactly, say, 250 degrees Celsius for exactly 30 seconds, and those parameters change even slightly for a new material batch.
Yeah.
The operator needs that update immediately, not 5 minutes later. Without this, even a slight deviation can lead to quality issues, material waste, or even machine damage.
Okay, so plans, parameters, what else? Instructions must be key.
Critically important. They need up-to-date instructions. And I mean the absolute latest standard operating procedures, SOPs, assembly guides, or work instructions for every single step of the process they're involved in. This isn't just about having an instruction. It's about having the most current and accurate instruction, one that reflects any engineering changes, process improvements, or quality updates that may have occurred just hours before.
Right.
The days of relying on those dog-eared, greasy printouts that might be 3 revisions behind are simply over if you want efficient operations.
That makes perfect sense. No more digging through binders or calling a supervisor just to confirm a spec from last month. It does like a truly information-rich environment you're describing. What else is crucial for those frontline workers?
Well, immediate notification of any changes and updates is paramount. Absolutely crucial. This could be modifications to production plans, like we mentioned, but also process adjustments or new quality requirements that have just been issued. Any shift in the production environment, no matter how seemingly small, needs to be communicated instantly to the relevant workstation or operator.
Okay.
And finally, something often overlooked. Notes from support teams are invaluable. This means critical, live information from maintenance regarding a machine's status or maybe recent repairs that might affect its operation. Or urgent insights from quality control teams about defect trends they're observing in real time. Imagine a quality engineer discovering a common defect pattern emerging. That information needs to be instantly pushed to the operators, who can then adjust their process accordingly, maybe increase their inspection vigilance, or even perform a quick preventative fix.
Yeah.
This proactive, real-time communication is just invaluable in preventing minor issues from escalating into major problems down the line.
That's a truly comprehensive list. It really highlights the level of precision and immediacy required on the floor. It really underscores the core principle we discussed earlier. The quicker and easier the access to this data, the lower the risk of errors and downtime, and the higher the overall efficiency. It's about empowering proactive operations, right? Not just reacting to problems after they've already occurred and caused damage. So here's where it gets really interesting, because now we're talking about how modern mobile technologies are stepping in to revolutionize this information flow on the factory floor. It's not just about identifying the problem anymore. It's about the innovative, practical solutions that are genuinely transforming how work gets done.
Exactly. We're seeing a significant shift in how companies deploy information, moving away from those static centralized systems towards dynamic distributed ones that meet the worker precisely where they are at their point of work. This involves a range of hardware and software solutions specifically designed for the, let's face it, rugged industrial environment.
Okay, like what kind of hardware?
On the hardware side, we're talking about durable mobile terminals, robust tablets, and dedicated workstation screens that are situated directly at the point of work. These aren't your typical consumer devices, you know. They're built to withstand the harsh realities of a factory floor, things like extreme temperatures, dust, oil, vibrations, and even the occasional accidental drop.
Right, they have to be tough.
They really do. They often come with specialized casings and are IP rated for ingress protection against liquids and particulates, built for purpose.
So it's about bringing the screen and the intelligence behind it directly to the task, rather than making the worker hike over to some central computer, which, let's be honest, often isn't even updated or conveniently located anyway. And what kind of specialized software ties all this together to make it truly effective? Because hardware alone isn't enough.
No, the software piece is absolutely crucial. We're talking about specialized mobile applications that are meticulously tailored for shop floor use. These aren't just generic apps off the shelf. They feature highly intuitive interfaces designed for quick data entry and information retrieval, often with large tactile buttons or touch targets suitable for gloved hands.
Ah, okay, practical design.
Exactly. They prioritize clarity and efficiency, minimizing the need for complex navigation or multiple screen changes. Just get the info fast. These applications offer a multitude of functionalities that were previously fragmented, slow, or entirely paper-based.
Like what?
For instance, they provide real-time production plans. Operators gain instant, continuous visibility into their exact schedules, upcoming tasks, and current output against targets, all updated in milliseconds. If a rush order comes in, or maybe a machine upstream experiences a brief stoppage, the operator's display instantly reflects that change in priority, or the adjusted throughput target.
Okay, very dynamic.
Very. They also offer dynamic operational instructions. This means access to the most current work instructions, standard operating procedures, or assembly guides, always accessible and always guaranteed to be the absolute latest version. So, no more time wasted searching for binders or worrying if the printout you have is actually the right one.
That sounds like it eliminates a huge amount of friction and just wasted time, really. But what about problem reporting or critical alerts? That's typically such a slow, cumbersome, often just verbal process, isn't it? How do these technologies address that particular headache?
Yeah, you hit on a key point there that transforms responsiveness. These solutions often include digital irregularity forms. These enable immediate reporting of issues, defects, or deviations directly from the workstation itself.
How did that work?
Instead of filling out a paper form, walking it over to a supervisor, and then waiting for it to be processed sometime later, an operator can log a problem instantly from their tablet. They can even attach photos or perhaps short videos to clarify the issue right there. This immediately sends an alert to the relevant support team, whether that's quality control, maintenance, or engineering, drastically cutting down on reaction time and allowing for proactive intervention before things get worse.
Okay, that's much faster.
Much faster. And for even faster issue detection and escalation, many of these systems integrate seamlessly with andon systems. This provides visual and auditory alerts directly on the device itself, signaling maybe a machine breakdown, a material shortage, or a critical quality issue that needs immediate attention.
So the alert comes right to the worker.
Right to their device, yeah. This prompts a quick, coordinated response from supervisors or maintenance teams without the operator needing to leave their station or, shout across a noisy factory floor. It's like having a digital pull cord right in your hand, but one that instantly broadcasts detailed information to exactly the right people who need to act on it.
That's truly the real game changer, isn't it? I mean, the key advantage here seems to be that workers can access critical information and act faster without having to leave their workstation. This minimizes all that unproductive movement, eliminates wasted time searching for answers, and dramatically reduces those waiting times we talked about. It's about keeping the flow going, keeping hands on the product, eyes on the task, and maintaining continuous, efficient production. It just makes sense. Okay, building on the power of mobile technology, let's shift our focus a bit to a specific, highly impactful technological advancement. Virtual instructions. This isn't just about, digitizing a PDF document, is it? It sounds like a whole new paradigm for how workers interact with their tasks, making complex procedures far more intuitive.
Indeed. Virtual instructions represent a really significant upgrade from traditional paper documents. They address so many of their inherent limitations that have frankly plagued manufacturing for decades. Think about it. Paper instructions are notoriously prone to being lost, becoming outdated almost as soon as they're printed.
Yeah.
Or becoming illegible due to wear and tear, grease, oil, or dirt in that harsh industrial environment. They're static, often one-size-fits-all, and frankly, quite inefficient for a dynamic, modern manufacturing setting where product variations and process changes are constant.
So the virtual aspect means they're not just digital copies, they're intelligent and adaptable.
Yeah.
Is that the key difference?
Exactly. That's the core idea. They offer dynamic and context-aware content, which is a massive leap forward. Virtual systems can automatically adjust the content displayed to the specific workstation or the precise product variant being assembled, or even the unique production order currently in progress.
Oh, okay.
This ensures that the worker is always seeing information that is 100% relevant to what they're doing right now. It eliminates confusion, reduces the need to search through irrelevant data, and minimizes errors significantly. For example, if you're building a specific model of an electronic device, the instructions for that exact model, including any unique components or assembly steps, appear instantly, not the generic family instructions that cover 10 different versions.
Right.
This eliminates the guesswork and the potential for applying the wrong process, which happens more often than people think.
Okay, so relevance is key. What else makes them better than paper?
Well, beyond just text, a major advantage is rich multimedia integration. This is huge. Virtual instructions can embed high-resolution photos, detailed videos, and even interactive 3D animations directly into the instruction flow.
3D animations, really?
Absolutely.
Yeah.
Imagine trying to describe a complex wiring harness assembly step with just static text and maybe a blurry black and white diagram from 10 years ago.
Yeah.
Versus allowing the operator to rotate a 3D model on their screen, zoom into specific connection points, or even watch a short video demonstrating the precise twisting motion required to secure a wire correctly. This makes incredibly complex procedures far easier to understand and follow. It drastically reduces misinterpretations, shortens learning curves, and cuts down on errors, especially for new or particularly intricate products.
That's a huge step forward for clarity and comprehension, especially in complex assembly tasks. I can see that being very powerful. And for accountability, or even just continuous improvement, can workers interact with these instructions beyond simply following them? Is it a two-way street?
They absolutely can, and this is where the system truly becomes a two-way communication channel, not just a one-way broadcast. Virtual instructions enable interactive feedback loops. Workers can confirm completed steps digitally, often with just a simple touch, maybe a barcode scan, which creates an immediate, traceable record of work done.
Okay.
This not only verifies completion, but also provides valuable data on actual cycle times for each step. But more importantly, they can flag problems directly within the instruction interface.
Like problems like what?
Whether it's a quality issue they've spotted, a missing part from their kit, or maybe a machine malfunction they're experiencing, they flag it right there. This not only alerts supervisors or quality control teams instantly, but also creates a valuable data point for continuous process improvement efforts.
Ah, so it feeds back into the system.
Exactly. It allows for immediate root cause analysis and proactive adjustments to the process. It essentially turns every worker into a potential sensor for process improvement, which is incredibly powerful.
This sounds like it's transformative for both onboarding new employees and optimizing ongoing operations. If I were to summarize, say, the two most critical benefits for the manufacturing sector that virtual instructions bring, what would they be, in your view?
I'd say the two critical benefits are, first, significantly shortening the onboarding time for new employees. New hires can become productive members of the team much, much faster when they have intuitive, multimedia-rich instructions, guiding them step by step through even complex tasks. It minimizes the burden on experienced trainers, too.
Okay, faster onboarding. What's the second?
And second, drastically reducing the number of operational errors. For experienced workers, having the most current, visually clear, and context-aware instructions minimizes the chances of making mistakes, even on repetitive tasks or when they're handling specific product variations that come up infrequently. It's really about empowering every worker, new or experienced, to perform at their best consistently and with confidence.
Okay, it's one thing to talk about these technologies in theory, but it's another thing entirely to see the measurable impact in the real world, isn't it? Let's provide some concrete examples now that illustrate the tangible benefits for our listeners. This really brings the abstract concepts to life and shows what's actually possible out there.
Indeed. And the source material provides some really compelling case studies that demonstrate the profound effects of implementing these types of communication and information delivery systems. Take, for instance, a home appliance manufacturing plant. Before implementing these solutions, their operators often relied on those cumbersome printed manuals we talked about, which quickly became outdated. This led to significant time spent double-checking things or making common assembly errors.
Right, a familiar story.
Very familiar. They recognized this issue and decided to implement tablets directly at the workstations, preloaded with real-time, step-by-step assembly instructions, importantly with embedded visuals. The results were quite remarkable. They achieved a surprising 30% reduction in assembly errors.
Wow, 30%. That's huge, especially in a high-volume environment like home appliances.
It really is. That's a direct, measurable improvement in quality and a significant reduction in rework costs and scrap. It hits the bottom line directly. It's not just marginal. That's a surprising game changer in terms of quality improvement and cost savings that many might not expect just from digitizing instructions.
Absolutely. What about streamlining communication for changes? That's a constant headache for many manufacturers, isn't it? Where a delay in getting a design update out can cascade into serious issues down the line.
It certainly is a major headache. Consider a furniture manufacturer mentioned in the material. They faced significant challenges with the speed and accuracy of communicating order changes to the production floor. Previously, a change order might mean a supervisor physically walking a revised printout to each affected station, or maybe even shouting instructions across the noisy factory floor. You can imagine how well that works.
Yeah, not ideal.
Not ideal at all. This manual relay was slow, inefficient, and highly prone to miscommunication, often leading to delays and incorrect products being made. By adopting a mobile application for real-time order communication, they saw a remarkable 50% reduction in the time needed to convey those changes to the production floor.
50%, half the time. That's incredible.
Incredible, isn't it? It vividly shows how much wasted time and potential for error exists in traditional manual communication methods. Imagine the agility and responsiveness that gives them in fulfilling custom orders or adapting to last-minute design tweaks. Cutting reaction time in half is truly transformative for a business like that.
No kidding. And what about reaction time to critical process parameters? That sounds like a key area for both efficiency and critical quality control, where every second truly counts, especially in some industries.
Absolutely vital, particularly in precision manufacturing. An automotive factory integrated a system of mobile alerts designed specifically to notify operators immediately about process parameter changes, maybe deviations from optimal settings, or potential issues detected by sensors on the line. Traditional alert systems often relied on, overhead flashing lights, or maybe a supervisor physically needing to stop the line, which could take precious minutes to react.
Right.
This proactive, device-based alerting system cut operator reaction time by a significant 40%.
40% faster reaction.
40%. In an automotive environment where precision and speed are paramount, cutting reaction time by nearly half can prevent major quality issues, minimize expensive scrap, and ensure consistent output. It directly impacts the reputation and, importantly, recall prevention efforts.
Yeah, huge implication.
Yeah. What's truly fascinating here, looking at these examples, is that these aren't just incremental improvements. A 30% reduction in errors, a 50% reduction in communication time, a 40% faster reaction time. These are not small tweaks around the edges. These are fundamental shifts that directly impact the bottom line, enhance product quality significantly, and dramatically improve operational agility. They powerfully illustrate that investing in better information flow directly translates into tangible, competitive advantages that really redefine what's possible on the factory floor.
These examples really do highlight the profound impact that focused technology can have. It's not just theory. Now let's talk about how specific platforms are delivering on these promises. Our source material points to DBR77 as a key player in this space, offering what sounds like a holistic ecosystem for information delivery. How does it manage to bring all these different pieces together effectively?
Well, DBR77 is presented in the material as a modern, comprehensive digital transformation platform designed specifically for industrial production and logistics processes. So its focus is right there. Its very foundation is built on combining cutting-edge technologies like the Internet of Things, IoT for data collection, digital twin for modeling and simulation, and artificial intelligence, AI for analysis and prediction, all unified through what they call an intelligent marketplace.
Okay.
Their overarching mission, as stated, is to directly address what they see as the core market problems. Specifically, a lack of precise operational data, insufficient process automation, and limited ability to quickly adapt to changing conditions. So you can see it's not just a point solution for one specific problem. It's conceived as an integrated system designed for factory-wide improvement, really tackling the problem of information flow at its root.
That broad capability sounds impressive, certainly. But how does DBR77 specifically connect to our core topic today, delivering information directly to the factory floor workers? How does it facilitate that immediate, precise access to critical data we've been discussing?
It does so, fundamentally, by establishing what they refer to as an integrated data hub. This is key. DBR77 is designed to seamlessly integrate data from all those disparate sources across the entire factory information, from planning systems like ERP, real-time quality control data, historical maintenance records from CMMS systems, and actual production data streaming directly from machines via IoT sensors.
Right, breaking down the silos.
Exactly, breaking down the silos. This is crucial because it ensures that there is a single, unified source of truth. It means everyone, from top floor management right down to the frontline operator, is working with the same accurate and up-to-the-minute information. This eliminates those dangerous data silos and significantly reduces the inconsistencies that can really plague complex manufacturing operations.
Okay, so the data is unified. How does it get presented to the workers?
Then, this integrated real-time information is presented to the workers through what they call virtual control panels. These are accessible from essentially any device, whether it's a large stationary workstation screen mounted on the line or a rugged mobile terminal or tablet that an operator carries with them. This highlights DBR77's human-centric design philosophy and its web browser-based approach, which simplifies broad access and, importantly, ease of use. This is key because it means workers aren't tied to a specific desktop computer somewhere. They can access precisely what they need, right where they need it, on a device that's easy and intuitive to interact with.
So it's about making sure the right information finds the right person at the right time, irrespective of their physical location on the floor. Makes sense. What about getting specific tasks or instructions to operators? Does it truly eliminate those paper-based processes for individual orders?
Yes, exactly. That's a core function. Production orders are delivered directly to the operator's screen, completely eliminating the need for paper printouts that, as we know, can get lost or damaged. And it removes the need for manual data entry of order details, which is notoriously prone to human error. But crucially, real-time virtual instructions are displayed.
Okay, the virtual instructions we talked about.
Right, providing that immediate, dynamic, and visually rich guidance for tasks. And this directly leverages DBR77's digital twin capabilities. Imagine not just a static 3D model, but a live, data-fed digital replica of your machine or your product.
Okay.
If IoT sensors detect, let's say, early tool wear or maybe a minor calibration drift in a machine, the digital twin within DBR77 can automatically modify the virtual instruction for the operator in real time, perhaps suggesting a slight adjustment to a feed rate or prompting them to check a specific component before a full breakdown occurs or a defect is actually produced.
Wow, so the instructions adapt based on real-time machine conditions.
That's the power of combining IoT and digital twin. It means instructions aren't just what to do, but what to do now, given the exact real-time conditions of the process. It's proactive guidance.
That's very advanced. And responsiveness. Alerts.
And to ensure that responsiveness, the system sends automated alerts in real time. These could be about critical changes in operating parameters, notifications of nonconformities detected by quality systems further down the line, or the need for immediate intervention due to a machine issue flagged by sensors. This directly connects to DBR77's use of IoT sensors for that real-time data collection and its AI capabilities for anomaly detection and predictive warnings.
Right.
This means problems are flagged instantly, often even predictively before they become critical, allowing for proactive rather than reactive management of the entire production process.
Okay, so it sounds very comprehensive. What about the practical side, overcoming those hurdles we mentioned?
Well, according to the source material, what truly sets DBR77 apart are its strategic advantages in overcoming those common implementation challenges. Its human-centric design, for example, prioritizes simplicity of use for all levels of technical proficiency on the shop floor, which really helps accelerate adoption and reduce resistance. The browser-based deployment is also a big plus. It significantly simplifies integration with your existing enterprise resource planning, ERP, manufacturing execution systems, MES, or warehouse management systems, WMS, via carefully designed APIs.
The integration point. That's key.
It's huge for IT teams. Instead of wrestling with complex, often proprietary integrations, DBR77's approach allows it to talk more seamlessly with your existing systems, breaking down those long-standing data silos that plague so many manufacturers. They also offer hardware solutions, including their own dedicated sensors, to help ensure high data quality right from the source, which is critical for good decision-making.
Makes sense. Garbage in, garbage out.
Exactly. And a unique aspect highlighted is their intelligent marketplace. This connects companies to a network of over 800 suppliers and 600 integrators. This isn't just a vendor list. It represents a fundamental shift in how complex industrial automation and digital solutions can be adopted. It sort of democratizes the process by leveraging an ecosystem of pre-integrated solutions and specialized expertise. This significantly lowers the barriers to entry and can really accelerate a company's digital transformation journey.
That marketplace concept is interesting. It tackles the how do I even start problem.
Yeah.
Okay, that's a truly comprehensive approach then, addressing not just the immediate information need, but also the broader challenges of integration, usability, and deployment. So what does this all mean for the bigger picture? If a company gets this right, beyond just reducing errors and speeding up processes, what are the holistic cascading benefits of this type of improved communication on the factory floor?
Oh, the benefits really do cascade throughout the entire organization. They extend far beyond just the immediate task at hand for the operator. First, and perhaps most obviously, are the reduced errors and customer complaints we've touched on. This directly leads to higher product quality, less rework, less scrap, and in turn, greater customer satisfaction and brand loyalty. When your products are consistently right the first time, your reputation soars and customer loyalty deepens significantly. That's gold.
Absolutely. What else?
Second is a drastically faster reaction to changes. In today's dynamic market, the ability to adapt quickly to new customer demands, to resolve material availability issues, or to implement process variations is a huge competitive advantage. When information flows freely and instantly, your team can pivot without friction, maintaining agility and responsiveness in a way traditional methods simply can't match.
So it's not just about what they do, but maybe how they feel about doing it. Is there an impact on morale or engagement?
Absolutely. There's a significant positive impact on enhanced team motivation and engagement. It's often underestimated. Imagine an operator who constantly feels like they're playing catch-up or making guesses, unsure if their instructions are even current. It's stressful and demoralizing.
Yeah, I can see that.
Now, contrast that with having precise targets, real-time feedback on their progress, and clear, dynamic instructions right there. They feel in control, they feel competent, and they feel like a vital part of a well-oiled machine. This isn't just a soft benefit. It translates into tangible results like reduced absenteeism, higher employee retention, and a more positive, proactive work culture overall. No one likes feeling unproductive because they're waiting for information or constantly confused.
That makes a lot of sense. Happier workers are often more productive workers.
Definitely. This also leads directly to quicker process change implementation. When you need to roll out new methods, updated procedures, or even entirely new product lines, the ability to disseminate new instructions and training materials digitally and instantly means changes can be adopted far more rapidly across the entire workforce. It minimizes disruption and accelerates your time to market for new initiatives.
Okay.
And as we touched on earlier with virtual instructions, it significantly streamlines employee onboarding. New hires can become productive members of the team much faster when they have intuitive, multimedia-rich guidance available at their workstation from day one. It dramatically reduces the learning curve and, importantly, the strain on experienced colleagues who might otherwise spend significant time training and hand-holding new folks.
Those are truly compelling benefits, really painting a picture of a much more efficient and, frankly, less frustrating workplace. No doubt about it. But as with any significant technological shift, it's rarely a perfectly smooth road, is it? Implementing such comprehensive systems isn't without its hurdles. So this raises an important question. What are the common challenges companies typically face when trying to bring this level of digital transformation to the factory floor? And maybe more importantly, how can they be navigated successfully?
You're absolutely right. There are definite challenges, and recognizing them clearly up front is the first step to overcoming them successfully. It pays to be realistic. One major hurdle is the sheer diversity of existing IT systems and the inherent complexity of integrating new solutions. This comes up again and again. Many manufacturing plants have invested heavily over decades in a kind of patchwork quilt of legacy ERP, MES, or WMS systems. These are often siloed, they don't talk to each other well, and they have limited interoperability.
Yeah, the spaghetti diagram of systems.
Exactly. Integrating a new real-time information solution with these disparate systems can be a technical and logistical nightmare, requiring significant time, specialized skills, and resources. The insight here is to look for solutions that were designed with interoperability as a core principle from the start, like, as we discussed, DBR77's browser-based system and its reliance on well-designed APIs. These approaches specifically address this integration pain point, making it much simpler than wrestling with traditional, complex, on-premise software integrations.
Okay, so integration is a big one. What else?
Another significant challenge, and one that needs careful handling, is employee resistance to new technology. It's the human element. Not all workers are digital natives, right? Some may feel apprehension, maybe fear of job displacement, or simply a lack of familiarity or comfort with tablets, mobile apps, or virtual instructions. It's not just about installing software. It's fundamentally about managing change, building trust, and ensuring people feel comfortable, supported, and crucially, see the personal benefits for them in their daily work. Forcing technology onto people without buy-in is almost always a recipe for failure.
So the interface design itself becomes critical then, beyond just the technical integration, partly to overcome that resistance, make it easy to use.
Precisely. The necessity of designing user-friendly interfaces with excellent ergonomics and real intuition cannot be overstated, especially for the factory floor. In a fast-paced, often noisy, and physically demanding industrial environment, an interface must be incredibly simple, crystal clear, and super quick to navigate. Workers might be wearing gloves, they might be operating heavy machinery nearby, and they need information at a glance, not after fumbling through menus. They don't have time for complex menus or tiny fiddly buttons. A clunky, confusing interface will quickly lead to frustration, rejection, and people reverting back to old, less efficient methods, completely negating all the potential benefits. Simplicity and clarity are absolutely paramount for industrial adoption.
Got it. Simple, clear, intuitive. Any other major challenges?
And finally, there's the very practical consideration of hardware robustness. We're talking about factory floors, remember, not climate-controlled offices. Ensuring that tablets, screens, or mobile devices can physically withstand harsh industrial conditions. This includes pervasive dust, dirt, constant vibrations from machinery, occasional accidental drops, maybe exposure to oils or chemicals, and extreme temperature fluctuations is a significant practical consideration.
Yeah, consumer tech wouldn't last long.
Not a chance. These devices need to be properly ruggedized with reinforced casings, impact-resistant screens, sealed ports, and often long-life batteries suitable for multiple shifts without needing a charge. This isn't a place to try and cut corners with cheaper consumer-grade tech. Investing in purpose-built industrial hardware is really essential for reliability and longevity in that environment.
Okay, so those are very real challenges. Integration, resistance, usability, and hardware. So knowing these challenges, what are the concrete, actionable steps that our listeners in manufacturing can take right now? If they want to improve their information flow and truly empower their frontline workforce, where should they begin? What's the roadmap?
Well, the implementation of such a transformative system really requires a strategic roadmap, not just a rush project thrown over the wall. The first critical step is to precisely identify the key information needed. Don't try to just digitize everything you currently have on paper. Pinpoint exactly what data is most critical for each specific workstation or role. This involves a thorough analysis, maybe conducting Gemba walks to observe workers directly in their environment.
Going to the source.
Exactly. Engaging directly with operators to ask them what information they wish they had immediately available. Reviewing your quality records to identify common errors that might stem from information gaps. Focus on the data that truly impacts performance, quality, and safety right at the point of work. Prioritize.
Okay. Identify the critical info first. Then what?
Once you know what information is needed, the next logical step is to select the appropriate technology for delivery. Will it be large stationary screens mounted above workstations? Will it be ruggedized tablets that workers carry with them? Or maybe specialized mobile apps on their existing industrial devices, if they have them? The choice really depends on the specific needs of the workstation, the environmental conditions, the type of information, and of course your existing infrastructure and budget. It might even be a combination of these across different areas of the plant.
Right. Tailor the tech to the need. And then comes the critical integration piece, right? How do you make sure the new system actually talks to everything else in your existing operational ecosystem? Avoid creating another silo.
Exactly. You absolutely need to integrate the systems effectively. This means meticulously planning how to connect the chosen solution with your existing planning systems, ERP, your production control systems, MES, your quality management systems, QMS, and maybe even your maintenance systems, CMMS. This ensures a seamless flow of data back and forth, eliminates the need for manual double entry of information, and avoids creating new information silos, which would defeat the purpose. While this can be a hurdle, as we discussed, looking for solutions with robust APIs and perhaps a browser-based deployment strategy can significantly simplify the stage, reducing both the technical complexity and the time required for integration.
Okay, integrate carefully. What's next? Pilot testing.
Following integration, it's absolutely crucial to test and gather feedback. Don't just attempt a big bang rollout across the entire company from day one. Pilot the virtual instructions or the new information delivery system in a limited controlled area, first perhaps just one production line or one department. Then actively solicit input from the frontline workers who will be using it daily. Their insights are invaluable for refining the system, ensuring its ergonomic design is right, and guaranteeing it actually meets their practical needs on the job.
Makes sense. Get user feedback early.
It not only builds buy-in and ownership, but ensures true usability before you scale up.
So once you've tested it and incorporated feedback, it's about rolling it out systematically and ensuring adoption, right?
Yes. Then you move to train and implement more broadly. Conduct thorough hands-on training for the entire team involved. Make sure everyone understands not just how to use the new tools, but crucially, why they are beneficial and how they will make their specific jobs easier and more effective. Focus on the what's in it for me. Then, integrate these new tools into daily operations as the standard expected way of working, not just an optional add-on.
Okay. And it doesn't stop there, does it?
No, absolutely not. Finally, monitor and refine. This isn't a one-and-done project. It's continuous improvement. Continuously track the effects, measure your key performance indicators, KPIs, like error rates, downtime metrics, cycle times, maybe onboarding time for new hires. Use the analytics generated from the system itself to identify areas for further improvement, perhaps in the content of the instructions, the format they're presented in, or even the underlying process itself. It's a journey of continuous improvement where the system evolves alongside your operational needs.
That roadmap is incredibly practical and actionable. Thank you. It really lays out a clear path. And ultimately, as you said, it circles back to the most valuable asset in any manufacturing plant: the employees themselves. What's the profound, lasting impact on worker performance when they are truly empowered with this kind of real-time, precise information? How does it change their day-to-day?
Oh, the effect is profound and multifaceted. It really transforms the very nature of frontline work in a positive way. When workers have instant access to clear, accurate, and context-aware information, they operate with significantly increased confidence and speed. That's the first thing you notice. They're not guessing anymore. They're not searching around for answers. They're not waiting for clarification from someone else. This certainty translates directly into more efficient, more precise work, reducing hesitation and boosting throughput noticeably.
More confidence, more speed. What else?
Well, this newfound confidence and clarity directly lead to reduced errors and defects. It's almost inevitable. When instructions are crystal clear, always up to date, and presented effectively, maybe with multimedia support for complex steps, the quality of the output naturally improves. This minimizes rework, reduces material waste, and contributes significantly to the bottom line while also enhancing your product's reputation in the market.
Right. Quality improves.
Furthermore, you see minimized downtime, just fewer unproductive pauses throughout the day because workers aren't waiting for or actively seeking information anymore. This optimizes the utilization of both your human resources and your machine resources, maximizing your overall operational efficiency. Less waiting, more doing.
Less waiting, more doing. I like that. And engagement.
And crucially, it fosters greater engagement and influence among the workforce. Employees feel more connected to the overall goals of the operation because now they have the context. They understand the why behind their tasks. They feel empowered to impact their work quality directly. It transforms them from simply executing tasks blindly to actively contributing to the plant's success and its continuous improvement efforts. They feel ownership.
That's a powerful shift.
It really is. If we connect this to the bigger picture, this isn't just about tactical efficiency gains, though it certainly delivers that in spades. It's about fundamentally transforming the relationship between information, technology, and human performance in these industrial settings. It elevates the role of the frontline worker, turning them into highly informed, highly effective contributors to the success of the entire operation. You're essentially moving from a reactive workforce to a proactive, empowered one.
That's a fantastic summary. In the demanding, fast-paced world of industrial manufacturing, information isn't just power. It truly is the bedrock of efficiency, quality, and, as you just highlighted, profound worker empowerment. What we've unpacked today really shows how modern technologies, from rugged mobile apps to intelligent virtual instructions, are making this bedrock stronger and more dynamic than ever before, enabling a truly connected and agile factory floor. So as you go back to your own operations, perhaps consider this provocative thought. What are the biggest, maybe the most frustrating information gaps in your operational landscape today? What hidden potentials, what untapped efficiencies, and what new levels of employee engagement might be unlocked by making that critical information truly accessible, precisely when and where it's needed at every single workstation? The answers might surprise you, and they could fundamentally redefine your factory's future potential. Thank you so much for joining us on this deep dive. Remember, these deep dives are custom tailored for a single listener for you. If you have specific challenges or areas you'd like us to explore with the same depth and insight, consider how a personalized deep dive could illuminate your own specific needs and unlock new possibilities for your organization. Until next time, keep digging deeper into what truly drives progress.